Hello everyone, welcome to the next lecture on the PY question series. Today we will come up with the complex integration as per your several requests. Myself Dr. Harish, I will cover all those questions from the CSIR NET from year 2011 to 2023. As usual, you can follow my YouTube channel where you will find the playlist of the CSIR NET, and here you can see the topic wise as well as the subject wise PY questions such as series of the real number, inner product, interpolation, power series, statistics portion as well. You can see the testing of 5 or 6 quadrature formula. Moreover, you can see the base as well as you can see this PY question of the calculus of variation, complete integral, and many more in this playlist. What is the objective is we will cover more than 22 plus question in this lecture, which covers from the part B and part C. As usual, we will explain you all the question with the help of the shortcut tricks. So before I start with these questions, let me briefly recall what is a complex integration. Whenever you have an analytical function, what is the meaning? How you can prove the f is analytical? You can easily verify whether it's a CR equation satisfied plus your partial derivatives are my continuously differentiable. Then you can say it's a analytical function. Whenever your function is analytic inside and on the closed curve, see, if I say this is my curve, see, what is the meaning of that? It means it is my here. It is inside and on the curve. So when you prove it's an analytical function, then the integration over this curve will be my 0, and this result is called as Cauchy theorem. On the other hand, if you have an area that is the integration will be 0 and the function is continuous, then the function is analytic over this simple connected domain, and that's called as the converse of the Cauchy theorem. Another important result is if you prove that the function is analytic function, then the integration is independent of the path. It means if you have the curve of this or you have the curve of this, that's the integration. If you prove integration is analytic or function is analytic, then the integration is independent of its path. And the last and most important thing is whenever you have the analytical function inside and on the curve, but A is the any point inside the C. What is the meaning of that? You can see A point is nothing but my pole of this here. Then how you can find this integration? By using the Cauchy integral formula. However, apart from this Cauchy integral formula, I will tell you the shortcut tricks how you can solve the problem within a 15 seconds in this video. Till then, you can simply scan and join my WhatsApp group if you want to join with me and discuss various questions. Okay, whenever you have the question of like this way, your first target is always to draw it graphically. Always remember, draw it on the graphically. But here, since the function is given in this form, so you can do it by firstly partial fraction. So you can see I can return this function as of this. Now how you can do it partial fraction? As I told you previously many times, you can substitute z is equal to 0 in this function. Apart from here, the function will be 1 over 2. When you substitute z is equal to 1 in all this function, apart from this, you will get as 1 and minus 1. When you substitute 2, it will be my 1 over 2. Fine. Now look at the first part. Here r is my anything. So you can choose any number in between them. Let's say I can choose the 2.1. So in this case, z is my 2.1. So whether this is my z minus 0, whether it lies in here, yes. 1 is satisfied this, yes, because this means minus 2.1, z is less than of this. So clearly say 0 satisfied, 1 satisfied, 2 satisfied. So what is the answer of this first part? Because 0 satisfied, answer will be 1 by 2. Is 1 satisfied here, 2 satisfied, answer will be this into 2 pi iota. Always multiply by the 2 pi iota when you integrate over this. Answer is 0, but he said 2 pi iota. So this answer is cancelled. In this case, you can take r is my any number in between them. Say r is 0.5. So clearly says this number is not lies. So this integration will be 0. This point is not lies, is again integration 0. Only this point lies. So answer will be half, whatever the reason of this, into 2 pi iota. So again you can see it's not equal to 1 by 2. Choose any number in between them, say 1.3. So 1.3, this number lies outside, so answer will be 0. these two numbers will be satisfied in this domain. So the answer will be half minus 1 into 2 pi iota. So it's a minus of this, again it's cancelled out. When you take any number of the r which is greater than of the 3, I can say 4, all are satisfied. So the answer will be half minus 1 plus half into 2 pi iota, and clearly say it's my 0. So the right answer is my D is the correct answer. Okay, again you can see I can firstly write this as 2 minus z, 2 plus z, and write it graphically. This is my center is my minus 1, radius is my 2, so this is my 1 and this is my minus 3. This is my curve. Now look at that, the point corresponding to this is my 2. Is it lies? 2 lies outside, so the answer will be 0. What is that? It's a minus of 2, minus 2 lies here. Then what is your answer will be 2 pi iota. Skip this part, at z is equal to minus of 2, fine, skip this part and substitute the value here. So minus 2 square, 2 plus 2, the answer will be 2 pi iota. Always draw it graphically and look at the various point lies on it. What is that? Z is a circle. You can see circle is center is 0, radius is 3 by 2, that means minus 3 by 2 and plus 3 by 2 is here. In the complex plane, in the anti-clockwise, in the counter-clockwise direction, which of the following is there? So I can write this as firstly fraction. So it is z minus 2, it's a z plus 1 plus a times z minus 1. Fine, this will be my 0. So look at that, 2 lies outside, so there is no problem. Z is equal to 1 is here, so z1 lies in between, sorry, minus 1 lies in between them. So what is the answer is 2 pi iota times, I can skip this portion, z is equal to minus 1, substitute here, this value will be cancelled out, this value will be cancelled out. So now this is cancelled out, so only value is 2 lies outside, the answer of this part will be 0. Fine, I think there is a mistake, it's a z minus 1, it's a z minus 1. So now it will not be cancelled, it's my z plus 1. Now z is equal to 2 lies outside, so there is no worry about this. Z is equal to 1 lies here and it is lies in between, so I can substitute z is equal to 1 in this side. So what is the answer of this is, when you substitute z is 1, it's a 2 over minus 1. Again z is equal to 1 here, I can substitute z is my here. So can you find the value of the a? A is my 2 from this case. Look at this another one. Z is a unit circle center at origin. So this is my here, this value is my 1, this is my minus 1. Then the integration will be in the anti-clockwise direction, like of this and here. So what is that? Z of this will be my 1. That's very simple. Now it's a mode of this. So I can return this number, because we all knows how you can return this number. It's a z into z bar. So I can open this as, what is the z bar of this? 1 z bar and z bar square. Fine. Now if I open this bracket, it's a 1 plus z bar square plus z into z bar plus this plus this. Fine. Now I can use this property, z bar of here. Clear? Now because the value of this is my 1, so what is the meaning of that? Z is nothing but 1 over z bar. So now you can see I can return as a 1. This value is also 1. Fine. This value is also 1. So 1 1 1, it is my 3. This value I can return this as z into z bar into z bar. So this value is my 1, this is my z bar. So this is z bar, it's a 2 times z bar. This is z bar square. What is that? Again this is my z, because z into z bar is a 1. So this is z, I can return as a 2 times. Now the remaining part is z bar square. This I already done, this is already done, this is my z square. Fine. Now I can substitute this value 3 I can return this number as here. So 2 over z, 2z, 1 over z square, and it's a z square. Fine. So I can simply take fraction is a separate, this part is separate. So 2 over z and 1 over z square. Fine. This part, integration of this, because this function is analytic, there is no pole, so the answer will be 0. In this case, again z is equal to 0 lies inside it, so the answer will be 2 pi iota, the numerator 2. It has a double pole. Fine, it has a double pole because 0 comma 0. So whenever there is a double pole, whenever there is a m number of the poles, you can write it as m minus 1 factorial of this number into the function which is in the left side. So you can see the function is my 1. So it has a double pole, so m is my 2. I can take the first derivative of 1 will be 0. Now this 2 pi iota cancel. Right answer is my C is the correct option. See the circle of radius 2 with the center is origin. Fine, so you can write it as a table graphically. It is my 2, this is my minus of 2. Then on this plane, so clearly says, what is that? Firstly you can say it is my 1, so 1 is lies here. Now 1 is of the pole which is of double nature. Fine, so we can say m minus 1 factorial of derivative of the function which is apart from this. So what is the apart from this is 1. So the right answer is 0 is the right answer. Or you all knows you can find the nth derivative will be n over 2 pi iota dz into, here is z minus z naught raised to power n plus 1, here is f of z. Fine, so you can see if you compare them, f of z will be my 1. Fine, this is the point at z naught, n will be my 1. So you can see the first derivative of this, again the first derivative of this is my 0, so the answer is still same of this. Okay, the value of this, okay, firstly I can write this in the graphically. Center is my plus 1, so plus 1 is my center. Radius is also 1, so this is my circle. Fine, this is the center, this is my here. Then your target is to write, I can write the denominator part as here. Now corresponding to this, z is equal to plus 1 which lies here. Corresponding to this, z is minus 1 and minus 1 lies outside, so there is no worry about that. Now corresponding this is a single pole. Fine, so I can skip this part, I can substitute the value of the z in this case, e raised to power 1 plus 1 into 2 pi iota. So 2 will be cancelled out, pi iota e is the right answer of this problem. Look at this another one. Consider the polynomial p and q in the complex plane of this. What is that? You can see gamma of t is my e raised to power iota. I can consider this as a z. So clearly says absolute value of this is my 1. So what is the meaning of that? It's a circle, center is 0, radius is my 1. Fine. Then which of the following statement is my true for all m is not equal to n? Very simple, I can say m is 1, n is my, because m and n positive integers and they are not same, I can choose m and n as here. So what is the I? This is z and this is z square. So I can say one is a p, second is the q. This is the integration of this. What is that? It's a z into z square. Fine. How you can do? I can return this into z bar of this. So clearly says that mode of z is 1, so this value will be by 1. So it is nothing but my here. Fine. Now how you can solve this integration? I can simply take z is e raised to power iota t. So what is the dz? Iota e raised to power this one. So I can substitute, this value is my e raised to power minus iota t into dz will be my iota e raised to power this one. So what is that? It's a cancel out over this d of t. Fine. So t is my varies from 0 to 2 pi of iota. So what is the right answer of this? 2 pi iota, but he said 0 is the wrong answer. Look at the second part. What is he said? Second part, he said for all the positive integer n. So what is the simplest positive integer? I can choose n is my 1. So this value is my z comma z. So what is that? Z into z bar. So what is that? Z into z bar is always a 1 integration over this one. So what is that? It is nothing but my, what is the answer of this? Can you integrate this? What is that? Z is my here. So the integration over this closed curve, how you can say that? Okay, you can say e raised to power iota of dt, because z is my here. So what is the integration over the 2 pi? It's a 0. Moreover, it's a complete circle. So over the closed curve, the answer will be 0, because this function 1 is my analytic. So once the function is analytic over this curve, the integration will be my 0 by using Cauchy theorem. So there is no need to write like of this way, because 1 is my, what is that? 1 is my analytic function. So whenever the function is analytic, then the integration over this closed curve C will be by 0. So but he said 2 pi iota. I of P1. So look at the C. Integration P is my any polynomial. P of Z complement of this. So what is that? P of Z into, can it be 0? Yes. Why? Because every polynomial is my analytic. So once the polynomial is analytic, what is the meaning of that? The integration of this polynomial is my 0. So the C is my correct option. Now since it is a part B, only one correct option is there. So this option is definitely incorrect. But how you can discard this option, we will see here. What is given to you for all the polynomial of this? Very simple. You can choose any of the polynomial. Say P and Q. A simplest to simplest polynomial is 1. Fine. Once you can take a 1, and this is also a 1. You can take, they are not talked about that they are distinct polynomial. It can be any polynomial. So then what is your integration? This is 1 into 1. So the answer will be 0, because this is my analytic. Fine. But look at the right hand side. What is the P of 0? 1. Q of 0 is my 1. So 0 is not equal to 1, which is nothing but P0 and Q of 0. So it means this option is discarded. Or you can choose any other polynomial as well. So if you choose the polynomial, let's say Z plus 1 is a first degree, and Q I can choose as a single 1. Then what will be your I? So I is nothing but Z plus 1. So clearly say this is my analytic function, because there is no pole. So its int is 0. But what is the P of 0? P of 0 is 1. What is the Q of 0? Is 1. And you can see the product of this will never be 0. So it means they are not same. So this option is cancelled. Right option is only C is the correct answer. Okay, what is that? If I consider Z is my 3 e raised to power iota t, so clearly says it is my here. So center is 0, radius is 3. It is already given. So you can draw the graph. Center is 0, radius is my 3. This is 3, this is minus 3. Then for what value of lambda for which these values are same? So what is that? Firstly, I can factorize it on the right hand side. This is my z minus 1, z minus 4. Now what is that? It is my 2. So 2 lies here. This is my 1. 1 also lies here. 4 is lies outside. So there is no worry about the 4. So what is that? 2 pi iota. Apart from the 2, this only the lambda. It's a 2 pi iota. It's a 1 is lies here. So apart from the 1, the answer will be, sorry, it's a 1. It's a 1. So it's a 1 over, I can substitute here. It's a 1 minus 4. So can you say value of lambda will be minus 1 over 3. A is the correct answer. Let's see with a counterclockwise circle with a radius half, center at iota. So center at iota, radius is half. Okay, so what is the iota? Iota is nothing but the ordered pair of 0 comma 1. So this is my iota, 0 comma 1. Radius is half, so this is half, this is 0 comma 1, so this is my 3 by 2. Fine. So this is my circle. Then the value of this integration, so dz, it's my z. I can factorize it. It's a z square plus 1. It is z plus 1, z minus 1, because it's a complex number. So I can factorize over the complex here, z plus iota, z minus iota, z plus 1, z minus 1. So look at that. This value is z is equal to 1. Z is 1, where is lies? Here, because 1 comma 0. Real part is 1, imaginary is 0. So which is lies outside. Minus 1 here lies outside. It's a plus iota is my here. So it is fine. It is minus iota. So minus iota is my here, which is lies outside. So what is the answer of this? 2 pi iota. I can substitute the value of z is equal to iota everywhere apart from the z minus iota. It means I have to substitute value of iota in these three cases. So what is that? It's a 2 iota. It is my, this component is my z square minus 1. So if I substitute z is iota, it is minus 1 of 2. So what is that? 2 iota will be cancelled. It's a minus pi over 2 is the right answer. Always draw the graph and look at the point which lies inside it and lies outside. If those point which lies outside, ignore them. Look at the point which is inside. I hope you can like my video as you feel it's very good for you. For any positive integer, any real number a, so I can choose a is my 1. It is easy for you. So what are the options? 0. Make sure the options are distinct. It is iota by 2. It is iota. It is 3 by 2 iota. They are the distinct. For any, consider the triangle with vertex 0, 1, 1 plus iota. Okay, so you can draw the graph. Fine. So it's a 0, 1. It's my 1 comma 0, 1 comma 1. So these are my triangle. Fine. O, A, B. This is my 1 comma 1. This is my 1 comma 0 and here. So the direction is my counter clockwise. This is there. Then the integration of the real part of the z, that is the x into dz. What is the dz is? Dx plus iota dy. Then which are equal to this? Very simple. You can break this integration into 3 portions. Firstly, on the OA. OA is x is equal to 1. So, sorry, x is vary, y is equal to 0. When y is equal to 0, the dy will be 0. The answer will be x dx. Range of the x is my 0 to 1. On this case, x is my 1. This is a constant. So dx will be 0. So this is my 1 into iota dy. So what is the value of the y is 0 to 1. On this curve, y is equal to x. So 1 is substitute here. Dx will be dy. So I can written as 1 plus iota dx. Limits are from x. So x varies from 1 to 0. So now over. What is the integration of the x square? It's a half. Integration of this will be iota is outside. It's a 1. X 1 plus iota is outside. So it will be 0 minus half. Now you can open this bracket. You will get as minus half minus iota by 2. So the answer is iota divided by 2. That is a B is my correct option. Okay, look at this another one. What is that? Center is my 1. Radius is 1. So this is my circle. Fine. This the center is 1. Radius is 1. So I can written this denominator as z minus 1. It's what are the roots are there? Minus omega and omega square. Fine. Now what is that? From here we can get z is 1. So 1 lies here. Z is omega. You know what is omega is? Minus 1 plus root 3 iota by 2. That means minus half root 3 over 2. So minus half is here and root 3 by here, which lies outside this circle. So the answer will be 0. Similarly, what is the omega square? omega square is minus 1 minus root 3 over 2 iota, which lies here again outside. So there is no worry about this. So what is the right answer of this? 2 pi iota. I can substitute the value of the z at this one. So what is the answer of this is 1 minus omega square, or I can return this part as z minus 1 z square plus z plus 1. Fine. So basically this number is nothing but 1 plus 1 plus 1. So it is, I can substitute here 1 plus 1 plus 1. 2 pi iota will be cancelled out. So the answer is my 1 over 3 is the right answer of the problem. Look at this another one. Gamma is a positive oriented circle, is again here. Center is my 1. Radius is half. So it's my from half, and radius is half is from my 3 by 2. So this is my circle. Fine. Then the integration of z e raised to power 1 over z divided by this case. So I can firstly break this denominator into the two portion, factorize them. Fine. Now you can see this value will be 0 when z is equal to 1. This value will be 0 when z is equal to minus 1. And you can see this portion will also goes to the infinity when z is 0, because once z is 0 it goes to the infinity. So it is also the part of here. Now look at that, 1 lies inside it. Fine. Minus 1 is here, which is not lies. 0 is again outside this, so it is not lies there. So the only portion is my here. So what is the right answer of this? 2 pi iota. I can substitute z is equal to 1 everywhere apart from this term. So it is my 1 e raised to power 1 over 1, and it is a 1 plus 1. So what is that? It's a 2 will be cancelled. Pi iota e is the right answer of this problem. Okay, f is a holomorphic function on the open disk. Center is 0, radius is my 2. Fine, it's an open disk. Remember, it's an open disk. Assume the only 0 of the f in the closed unit disk is a simple 0. What is the meaning of the simple 0 is? Simple 0 at the origin. So what is the meaning of that? It means z minus 0. The power of this is 1. It's a simple 0. Assume f is there. So what is the meaning of that? What is kind of the f? F is nothing but z minus 0 into some another function like of say g of z, where g of 0 is my non-zero, because if g of 0 is my 0, then it has a double root or double 0, but it simply says it's a simple 0. Let gamma is the positive oriented and your target is to make over this integration. So you can draw this circle. Center 0, radius 1. Fine. Then the integration over this f is z into d. Fine. Now clearly says what is the pole of this? Either this will be 0 or this will be 0. But over this circle, he said the only zeros of the f is my here. So that means I have 2 pi iota into the function value of the z is my 0. Fine. So the answer is 2 pi iota over g of 0. But the answers are in the form of the derivative. So clearly says what is my f? F is z into, so can you find the f0? This is z into this plus, now what is the value of the g0? I can substitute z is 0, so this value will be cancelled out. It is my f dash of 0. So f dash of 0 is the C is my right answer of this problem. Okay, look at this another one. Again, this is a circle with center is 0, radius is 3 by 2. So this is my here minus 3 by 2 plus 3 by 2. Then you have to write it here. So this part is z minus 1, z minus 2 iota square. So firstly we will check of if both the points lies in this, then we will do the partial fraction, otherwise no need. Here z is my 1, so 1 lies here because it's a 0, it's a 1.5. What is the value of the z of 2 iota? What is the value of the mod of this? Is my 4, sorry, it's a 2. Fine, mod is nothing but the z square is nothing but here, so 2 is lies outside this, so there is no role of this. So what is the right answer of this? 2 pi iota. I can substitute z is equal to 1 in here. So what is that? E raised to power iota pi divided by 1 minus 2 iota square. The one way is you can open this bracket and rationalize it, but we all knows what is the meaning of the z square, z into z bar, or you can simply take as a modulus of this. So what is the 1 minus 2 iota? It is my 1 plus 4 is root 5. So what is the square of this? Is 5. This is 5. What is the e raised to power? This is minus 1 because it is nothing but cos pi plus iota sin pi. This is the value of the e of, so this value is my minus 1, this is 0. So what is the right answer of this? So 2 pi iota c, so c will be my minus 1 over 5, and they are talking about the mod of c, it is my plus 1 over 5 is the right answer. Okay, look at this another one. Gamma k is a circle and here is k of theta. Okay, that is the interesting thing. Because of this k, which of the following are necessary true, where k is 1, 2, 3. Okay, we can firstly find over this gamma 1. So what is the gamma 1 is? 1 e raised to power iota. That means circle with center is 0, radius is 1. So this is my circle, center 0, radius 1. This is for my gamma 1. So what is the integration of this? 1 over z over this gamma 1. So I can say it's a 2 pi iota because the center is here is 0 and 0 lies here. So I can say 2 pi into the function of the remaining. So here is 1 by 2 pi iota. So the answer will be 1, which is non-zero. So this option is cancelled. Fine. Once this option is also cancelled, so can you say, now look at that for the second option gamma 1. I can solve this gamma 1, it's a 1 and it's a 1. So B is the right answer. But it's a part of C, so now we can do for the gamma 2. What is the gamma 2 is? Gamma 2 is my twice e raised to power 2 iota theta. So what is that? It's again a circle with the radius 2. Fine. Then I can solve this. What is that? It's a 2 pi iota. Again this value will be my 0. If 0 lies here, 2 pi iota times of 1. But here you can see the angle is my double, because whenever angle is 0 to 2 pi, this number will be my 0 to 4 pi. So it means it's a double of this. So I have to multiply by 2. Now because of this 2 pi iota, this value will be cancelled out. It is my 2, but he said 4. Option is cancelled. Now for the gamma 3. Gamma 3 will be my 3 e raised to power 3 iota z. So what is that? What is the integration of this is? 2 pi iota. Integration is 1. But you can see what is the value of 3 theta. You can see from 6. That's a 3 times of this. You can see it's a 3. So 2 pi iota will be cancelled out. Answer will be 3. So it's a matched. So the right answer is my B and D. So that's an interesting question because of this presence of the k. Okay, till now what we have discussed here is all are my radius. That is the only unit circle of the one rotation. But here is my k rotation. So that's why it's a multiply by kth r. Okay, look at this another one. If f of z is my entire function, r is my a positive real number. So you may choose r is 1 if you want. Okay, then which of the following is here? Okay, Do you remember any of these results which relate with the summation and integration? Do you remember any of the results? Yes, that is called as the Parseval theorem. Fine. What is the Parseval theorem is? That means if you have this function r of 2n from 0 to infinity, it will be less than of the area from 0 to 2 pi f of z square into d of z. Here z is written in here. Now look at the options. So first of all, okay, look at that. I can written z in the polar form is er of this. Fine. So z is my here. Clearly says this option is nothing but my Parseval identity or Parseval theorem. So C option is directly correct. Now in all those options we need a supremum of this. So very simple. I can assume M is my supremum of f of z over the domain mod of z is my r. Fine. Now I can substitute this value. What will happen? This will be less than of 1 over 2 pi. This number is my supremum m, so it's a less than or equal to m square. Integration is outside over the 2 pi of this. What is the integration of this? It's a 2 pi cancel out. It is less than of m square. So this summation an square r of 2n is less than of m square. But first one is, this is, what is that? This is, if m is my here, so what is that? This is nothing but m square. Fine. So the first option is correct option. He said supremum is less than of the here, but that's the wrong option. Again he said supremum is less than of this. That's the wrong option, because this value is my supremum. It must be less than of m square. That's a reverse part. So the right options are my A and C are my correct options. Okay, look at this another one. D is the unit open disk center at 0 in the C. Is a unit disk. Center is my 0. F is my analytic function. F is given to be analytic, and f of z is given to be, here is a power series. There is no integration. Why is it considered here? Okay, the option is involved in the integration. Okay, this, because the option is involved in the integration, that's why you consider this problem in this video. Okay, then if f is a power series, then f is constant if these options are satisfied. Okay, basically this question is a power series question, and I already explained the same question in our previous power series video. How you can see, what is the first step is, we all know if f and f complement or f conjugate are my analytic function, what does it means? It means f is my constant function. The first result for here. Now look at the first one. He said f is constant. If I prove f and f bar, f and this are my analytic, then this means they are here. F is analytic, it is given to you. F is analytic, it is given to you. Now if you look about the first part, if I assume f bar is also analytic, if and only if f is constant, so that means this option is a correct option. Fine, because of this result. Look at the second part. U of half is greater than or equal to u of z for all the z in the domain. What is that domain is? Collection of all those z such that it's a unit circle of, is open unit disk of this one. Fine, center at 0. Now what come in your mind whenever in the complex analysis a greater than or less than sign? Either you can use the maximum modulo principle or the minimum modulo principle, but the sign is here is greater than, so you can apply the maximum modulo principle. What is the meaning of that? First of all, f must be analytic, that is given to you. Second, whatever the point, if I say u of a is greater than of this number, provided a must be in the domain, then you can say f is my constant. That is the simple tips for you. Now since f is analytic, it is already given to you. This is already given to you, but you need to prove half belongs to the D, because here is my here. If you prove half is belong to the D, it implies f is constant. Now clearly says that half is less than 1. It's satisfied. It means f is my constant, is the correct option. Look at the third option. How you can see that a set is my infinite. An is 0. Look at that. This is my an. Can you find the relation of this an with the function, analytic function? Yes, you can find. This is my center over n0, where z0 is my center of the power series. You can see the center is my 0. So basically this is my 0 over n factorial. Now collection of all those n are very simple. You can simply take f is sin z. What is the first derivative? Cos z. What is the second derivative? Minus sin z. What is the third derivative? Minus cos z, and so on. If I calculate the fourth, it is my sin z, and so on. Now what is the a1? a1 first derivative at the point 0, it is my non-zero. a2 sin 0 is my 0. a3 non-zero. a4 0, and so on. So what is that? The set n. What is kind of the set? 2, 4, 6, and so on. So clearly says this set is my infinite set. So this option is also correct option. Look at this one. The last option will be my, I can rub this part for here. So look at the last option is integration of fz divided by z minus a whole square of dz is 0. Fine. So what is the meaning of that? Z is equal to a is my double pole. Fine. Once it's a double pole, then we can, how you can solve this? That's a 2 minus 1 factorial into 2 minus 1 times derivative of this function. It is to be 0. So what is the meaning of that? What is the first derivative is? Here is my 0. What is the meaning of that? F is my constant. So it means this is also my correct option. Sorry, this is wrong option. It satisfies the infinite set, but what I consider is sine of z, but this is a not constant function. So this option, our target is to check whether it's a constant or not. So third option is a wrong option. So the right answers are A, B, and D are my correct options. Look at the next one. Consider the function f of z such that, okay, what is the f of z is integration 1 over x minus z square over dx. Okay, dx. Then there is a meromorphic function, that analytical function g, that agree with f of z. F of z is agree on the g when imaginary part of this z is my greater than 0, and this integration is already occurring here. Then f pole of the g. So your target is to find the pole of this. Okay, remember this simple tips for you. Whenever the two function f of z and say another function g of z agree on the connected domain, fine, because this is my clause here. Fine. What is the meaning of that? This means f of z is my g of z for all the values of the z. What does it means? The poles of the f is same of the poles of the g. Zeros of the f is same of the zeros of the g. Now your target is to find the pole of the g. So I can find the pole of f. How you can find the pole of the f? The pole means the function is not analytic. So clearly says when I take z is my 1, when I take z is my 2, so this integration becomes my here So clearly says at 1 the function is not defined. Or if I take x minus 2, then clearly says this upper 2 is not defined. So what is the meaning of that? 1 and 2 are my poles of f. Once f and 2 are my poles of the f, then f and 2 are my poles of the g as well by using this shortcut trick. So 1 and infinity are the poles, cancel. 0, 1, infinity are the cancel. 1 and 2 are the simple pole. Fine, because there's a single one, so it's a simple. Fine. This is the first way. Second way is, if you look about this graphically, that's fine. Otherwise you can integrate them. So what is the integration of this? I can return with respect to x. So what is that? It is minus 1 over x minus z. Fine, from 1 to 2. So when you substitute here, it is 1 minus z and 1 over 2 minus z. Clearly says z is equal to 1, z is equal to 2 are my poles known as the single pole of the f. So once they are the single, so you can say they are the simple as well. So the right answers are C and D are my right. Otherwise you have to substitute, look at the options and you can write the function accordingly. You will get the answers quickly. Okay, look at this one. Is a June 2023. Gamma is a positive oriented circle, radius 3, center 0. So this is my here 3 minus 3 is 0. Then the integration of 1 by z square e raised to power z minus of this. Fine. So again your target is to firstly find the pole. So clearly says from here z is 0 and 0 is a double pole. Also you can see z is equal to 0 again satisfied here, because 1 minus 1 is 0. So it means 0 is the triple pole. Fine. Then and no other pole are. So what is the meaning of that? Since again here and again here, so how you can solve that? The first method is, because it has a triple pole, so I can written as a 1 over 2 factorial. Second derivative of, I can multiply by z cube. Basically what is the z cube is, because the pole is my 0, so z minus cube into this function. Fine. E z minus, so what is that? It's a second derivative z over e raised to power z minus, here you can find the second derivative at the point z is equal to 0. This is the first way. But you have to take the 2 times derivative, then it may appear as a 0 by 0 form or infinity by infinity. Then again you have to apply the L'Hopital. Otherwise the second way is, you can equate the coefficient of 1 over z. Fine, because z is a z minus 0 basically. How you can do? What is that? This is nothing but 2 times sine hyperbolic z. So I can written as a 2 of z square. Sine hyperbolic z, I can open that z cube over 3 factorial, z raised to power 5 over 5 factorial, and so on. I can take as a z is common, so it's a 2 of z cube. Rest portion I can written as z square over 3 factorial, z raised to power 4 over 5 factorial, and so on raised to power minus 1. So what is that? I can expand this series 1 minus x z cube over 3 z4 over 5 and so on plus x square plus so on. Now I need to compute the coefficient of the 1 by z. So I need to equate from here the coefficient of z square. Fine. So now you can see that 1 over 2 is here. What is the coefficient of the z square? 1 is my this portion. Is there any other term which appears in the z square? No. So the coefficient will be my 1 over 3 factorial. Fine. Finally multiply by 2 pi iota. So what is the right answer of this? It is 1 over 2 is outside. So it will be, what is that? 2 will be cancelled out. pi iota divided by 6. Sorry, it's a minus. It's a minus 1 by root 3. So minus 1 by root 3 is a minus pi iota by 6 is the right answer of this problem. Fine. Either you can write a 2 times derivative, again you will get the same answer. Okay, again it's a June 2023. D is the open unit disk. Fine. So this is my open disk of here 1, 2, minus 1. C is my positive oriented boundaries fixed on this. So C is my, I can return C is my here boundary points. Fine. For the fixed point here, okay, it's a fixed point. I can choose N is my 2. Fine. So then you have the 2 points Z1 and Z2, so that you can get easy. What is my G of Z? It is my Z minus Z1, Z minus Z2. Degree of polynomial 2. Fine. F is a holomorphic function in the open neighborhood of the D bar. Okay. So this is my D. Fine. What is the D bar is? Outside them. So F is a holomorphic function outside this here, and P of Z is defined to be this. So then your target is to prove F is a polynomial of degree 2, F is a polynomial of degree 1, P is a polynomial of degree 2, 1, and then so. Very simple. How you can think about that? First of all, F is a holomorphic function, and the answer is, the first answer is independent of F. Fine. Second answer is independent of the F. Third answer is independent of the F. So it means you can choose F of Z is any function, which is basically a holomorphic. I can simply choose F is my constant. Fine. Clear? If I choose F, or moreover, if I simply choose F is my 0, again it is my analytic function. Fine. If I substitute F of 0 here, what is my P of Z? P of Z is my 0. So is it a polynomial? Yes. This is a polynomial, fine. But is it a degree 2? Because it's a polynomial. What is the degree of the 0 polynomial? Degree is not defined. Fine. So once the degree is not defined, definitely it is not the polynomial of degree 2. It is not the polynomial of degree 1. P is a rational function. Okay, I can take as a 0 over 1, but has a pole of Z1 comma Z2, but it's a 0 polynomial. It has no pole. So this option is also cancelled. So only one option is pending, which is my correct option. But how you can solve that? So basically your target is to prove this for I have chosen N is my 2, 1 comma 2. So what I can do, I can simply choose, firstly I can say P of Z1. Fine. If I substitute here, F is the any function. What is a G of Z1? You can see here. What is a G of Z1? It is my 0. So this is my 0. This is Z minus Z1 of G of xi. Fine. Now clearly says this value will be cancelled out. What is that? This is F of xi over this. What is that? Can you find the integration of this? Because this is nothing but my xi of Z1 by using, what is the root of this? What is the pole of this? So xi, because we are integrating over the xi. So xi is my Z1 and Z1 is the fixed point of this. So definitely it will be my here. So, or you can use the by Cauchy theorem. Fine. So P of Z1 is my F of Z1. The first property is satisfied. Now similarly, if I take Z2, again G of Z2 is 0. Here will be my Z2. This is my Z2, then it is my Z2. So the right answer is my D is my correct option. Okay, look at this another one. What is given to you? P is my any positive integer. P is my any positive integer. Fine. Consider the close. So I can say this is nothing but circle of radius 1. Fine. This is given to you. Let F be the holomorphic function on this, where R is my greater than 1. but that is basically outside. Fine. Then f has a 0 only at z0. f has a 0 only at z0, and the multiplicity is my q. What is the meaning of that? A function will be my z0 raised to power q of g of z0, where g of z0 is my non-zero. Fine. Then okay, very simple, since which is given to be like this way, so I can firstly give you the shortcut tricks. Whenever the function is written in the form of the derivative and of this, how you can solve that? You all know, you can think about the number of the zeros, number of the pole, or in general, if I call this is my say h of z, I can't take as a g because g I already used here. Then this is called as, how you can define that? This is h of ai's into ni minus h of bi's and pi's. What is the h, b, and here? N is called as the multiplicity. N is called as the multiplicity of the 0. P is called as multiplicity of pole. Fine. What is the AIs are? AIs are called as the zeros of the f, whatever the function. B is called as the pole of the f. Fine. Now look at that. What is given to you? F is my holomorphic function. So if f is my holomorphic function, what is the meaning of that? Okay, this is with respect to I. So it's a summation I varies from 1 to how many are there. If f is holomorphic function, what is the meaning of that? There is no pole involved in it. Once there is no pole of this, it means bi is my 0. Fine. And what is the capital Pi? What is the multiplicity of the pole? If there is no pole, multiplicity will be 0. So it means this portion will be my cancel. Now if I substitute here, what is the ni? Multiplicity of the 0. It is given to you as a q. So this value, and there is only, it means I summation I varies from 1 is only one time. So what is the answer of this? H, what is that function having the 0 is my here. So what is that? H, h of ai. H, if you compare them, h is my, okay, firstly you can say h of ai. What is the 0 is? z0. What is the multiplicity is? Q. Now you can substitute what is the h0. If you compare this function with here, so h is my z raised to power p of this. So that's the right answer of this problem. So A is my right answer of this problem. So you can see, with the help of this simple result, you can solve this problem in a very simple manner. Remember, this is a very simple tips for you. Number of the poles, number of the zeros. I hope you can simply learn the various tricks. You can simply like my video as well. We will see the next lecture on the sequences of the real number from the year 11 to 23. Till then, you can simply like, share and comment my video. Best of luck, students. Happy learning.